Hi, in this video, we're going to go over the practice problems for composition of function. And just a quick reminder, the notation of a composition of function is f of g of x. And this is like a small circle. It's not a zero and it's not a dot. And this does not mean f multiplied by g. So this is the most common misconception or mistake. We're not multiplying those functions when we talk about composition of function. And this will be explained in questions 11 through 14. Now, questions 1 through 4 ask you to do very traditional operations like adding the functions, subtracting the functions, and when you see f G right next to it, that means there's a dot in between, and this simply means multiply them. So in the first set of problems, we're just doing very traditional operations. So number one, we'll have three parts, f plus g, which simply means add those two functions. So 2x minus 1 plus x squared, done. I combine like terms. If there's any, there's none. It's best if I reorder in a standard format. Ax squared plus bx plus c. This would be a quadratic function. Before we do number two, I need to subtract. And the trick with subtracting is make sure when you have a negative next to the parentheses, if you have multiple terms after that, you must distribute the negative. Now, in this case, we don't have multiple terms after the negative, so this would be fine. If I want to rearrange, I want to make sure the x squared has a negative coefficient, so that has to go with that. The 2x is positive, and the negative 1 has a negative, of course. Now I need to multiply them. So I need to multiply 2x minus 1. I multiply it by x squared. And this is when I need to distribute. So 2x cubed minus x squared. And it will be very similar for number 2. So f plus g is going to be x minus 1 squared and plus the g function. And we talked about this special case in our special cases bulwark. So this is a special case. I do not need to write it twice. I do not need a box for it. I need to square the first term. Then if this is a minus, then the double product is a negative. 2 multiplied by first, multiplied by second, and plus the second term squared. And plus 3 minus x. And I want everybody to get used to that special case. We don't want to use a box. We don't want to write it twice. So x squared minus 2x plus 1 plus 3 minus x, which will give us, if we combine like terms, x squared minus 3x plus 4. Now we need to subtract them. So actually, I don't need to repeat how I distribute this, so I can take the end result. So it will be x minus 1 squared minus the other function. And this is what I meant by make sure you keep your parentheses, because that negative has to be distributed. I'm not going to redo this. I'm just going to, again, take the end result. So x squared minus 2x plus 1 and minus 3 plus x. And if I rearrange it, combine like terms, it will be x squared minus x and minus 2. Okay. So this was for adding, subtracting. Now, if I want to multiply them, so I'm still on number 2, and I am multiplying those functions. So I'm multiplying x minus 1 squared, and I'm multiplying 3 minus x. And again, I'm not going to redo this because I already did it here. I expanded it. I distributed it. So I'll take the end result. and I'm gonna multiply it. So here I'm gonna FOIL. I have no choice. So x squared times 3, 3x squared times negative x, that's negative x cubed, and so on. So you can keep track, negative 2x times 3, and that will give us negative 2x cubed, and plus 3 minus x. Now I rearrange, combine like terms. Those are the cubic terms. So that would be negative 3x cubed. I only have one x squared term minus 7x plus 3. So we multiply them. Number 3 and 4 are pretty simple. You can see we have a radical and we have a sine function. So those aren't alike. So when I add them, there's nothing else to do except writing it that way. There's no like terms to combine them. When I subtract them, same thing. When I multiply them, I also have to write like a multiplication sign and done. This is all what I gotta do. Same thing for number 4. Also, when I add them, so I have no choice. There's no common factors, and I cannot remove the absolute value. So I can't do anything about it. I just leave it as is. I cannot get rid of the absolute value. I cannot get rid of the square root. I'm not solving. I'm just adding two functions. I'm multiplying two functions. I'm subtracting two functions. So that will be the resulting operations. So this will be 1 through 4. Now 11 through 14, and I'm gonna need more space to write. So let's scroll this screenshot down so we can use it. 11 through 14 is not the traditional operations that you guys know. It's something pretty new, which is denoted as f of g. So it's a small circle of 3, which means they gave us a specific input. And g of f of negative 2, also it's a composition of function, and they gave us an input. The very common mistakes that I found were that many students multiplied f by g. This is not the case. If they want us to multiply them, this is how they would write the notation. They don't want us to multiply them. This is a composition of function. We're applying two functions one at a time, starting by the inside, going to the outside. Another common misconception that I saw is that some students did the composition of function right, but then the result, they multiplied it by 3. And I'll give an example as we move on. 3 is not a number that we multiply the function by. 3 is an input. And the negative 2 is also an input. So we need to plug it in. Let's start with number 11. There's two ways to do this type of problem. So f of g of 3, I need to rewrite it, and don't forget your parentheses. F parentheses g inside of it, and not of x in this case. It's a specific input. So it's a 3. Now this means plug 3 in g, then the result, plug it in f of x. So this is one way of doing it. So I'm going to take 3 and I'm going to plug it in g. So g of 3 is 3 plus 1, which is 4. Now this result, I'm going to take it and I'm going to plug it in f of x. So f of 4 would be 2 times 4 minus a 3, which is 8 minus a 3, and it's a 5. Now I can write all this in one step. It's up to you if you feel comfortable doing it. I could do f of 3 plus 1, which is f of 4, which is 2 times 4 minus the 3. Again, I do not mind whether you write it in 2 steps or 1 step. The other way of doing this, and I saw some students doing it, which is nice, like I explained in the video, you can do the general one. So I'm gonna plug g of x in f. So I'm gonna get the general function. So it's gonna be 2 multiplied not by x, but by the whole g of x, which is x plus 1, and then minus the 3, which if I distribute, I will get 2x plus 2 minus 3, which is 2x minus 1. Now, here's the deal. Many students, when they got to that point, they took this function and they multiplied it by 3. No, this is incorrect. If I want to find f of g of 3, I have to plug 3 in the resulting function. So this is f of g of x. It's a composition of function. It's a combination of those two functions. So I'm going to plug 3 as an input. I'm not going to multiply this by 3. So it will be a 6 minus 1, which will also give us a 5. I'm just going to do that first one with the 2 methods, but the other ones I'm going to do them with 1 method. And again, you guys can choose whether you want to work in general and then plug in or plug in first. So this is a second method. And of course, we need to also find f of g. I'm sorry, you need to find g of f of negative 2. So g of f, what this is different from the first one because it's g of f of negative 2, which means plug in negative 2 in f of x, and then the result plug it in g. So f of x is 2x minus 3. I'm going to plug negative 3 in it. So it will be g of negative 4 minus 3, which is negative 7. Now I plug negative 7 in g of x. And again, this does not mean multiplied by. This means it's an input of g. So this is very important to understand. So negative 7 plus 1, which will be negative 6. So this is for number 11. For number 12, again, I'm just going to use 1 method. So I need f of g of 3. So I'm going to plug 3 in g of x. So f of 2 multiplied by 3 minus 3, which is f of 3. So now I plug 3 in f of x. It's an input. So 9 minus 1 equals 8. And I want g of f of negative 2. So I'm going to plug in negative 2 in f of x first. And I'm going to leave g waiting right here. So g is waiting. I'm going to plug in negative 2 minus, so squared minus 1 because the function f of x is x squared minus 1. So g of 4 minus 1, which is g of 3. Now I plug 3 in g. So 2 times the 3 minus the 3, which is 6 minus the 3 equals a 3. Number 13. Also, same process, f of g of 3, just the functions are different. So I'm going to plug 3 in g of x, which and f is going to be waiting. And it's f of square root of 4, which is 2. And now I plug in 2 in f of x, which is going to be 2 squared plus 4, so 4 plus 4, which is also 8. G of f of negative 2. I'm gonna rewrite it. The key is to rewrite it. Know how to rewrite it. Now start with inside, then go to the outside. G is gonna be waiting. And I'm gonna plug in negative 2 in f of x. So negative 2 squared plus 4. The G of 4 plus 4 is 8. Now I plug in 8 in a G of x, which in this case is the square root of 8 plus 1, square root of 9, which is 3. And the last one, which is number 14, also same process, just the functions are different. And you guys can have the questions in front of you. I have the little screenshot at the beginning of the video. So the key is that I'm gonna rewrite it. I'm gonna plug 3 in G and f is gonna be waiting. So 9 minus a 3 squared, it's gonna be f of 0. Plug 0 in f of x. So 0 over 0 plus 1. A common mistake when I saw the work is that some students did this and that's equal to 1. Incorrect. I disagree. So it's 0 divided by 0 plus 1. We can never simplify a fraction when there is a plus. When there's addition, I cannot touch the fraction. 0 over 0 plus 1 is just 1. And 0 divided by any number equals to 0. Now, g of f of negative 2, I'm going to start with plugging in negative 2 to f of x. And g is going to be waiting. So negative 2 over negative 2 plus 1. Same note. I can't do this and say it's a 1. That's incorrect. It's equal to g of negative 2 over negative 1, which is g of 2. And now I'm going to plug 2 in g of x. And this is going to be 9 minus 2 squared, which is 9 minus 4, which is 5.